Hello and welcome to this video where we're going to graph some piecewise function, and then we're going to determine its domain and range and any intercepts it may have. So first thing we want to do is zone in on this part right here. There's only two parts to this piecewise function, and it is going to be split along the y-axis. So what I'm going to do is go to the y-axis, and then since it is on a dark line, I'm going to do this in yellow. I'm just going to put a dashed line here. And so what this represents is the barrier. On the left-hand side, if x is less than 0, I'm going to be graphing the picture 1 plus x. On the right-hand side, though, I'm going to be graphing x squared. And so now it's all about graphing these. And there's two ways we can go about it. And fortunately, this is going to be fairly easy for us, but given that we're splitting it at the y-axis, we can just either draw the graph just where it exists, or you draw the whole thing and then you erase it where you don't need it. But since we're splitting it at the y-axis, it will make life a little bit easier for us. So let's start off with 1 plus x. So 1 plus x is going to be it's going to have a y-intercept of 1, and then up 1 over 1 or down 1 over 1 for its slope. So again, since it's at the y-intercept, I can just go right here, and I'm going to, whoops, let's not do that like that. Let's try it again. There we go. Draw it going like this. Perfect. Now I'm going to draw the graph of x squared. Well, x squared is a parabola, and so it's going to have, and it's a very simple parabola at that, so it's going to start down here at the origin. It's going to go to 1, 1, and then 2, 4, and 3, 9. And so I'm going to sketch this out like that. Perfect. Now, what I need to do is focus on what's happening when x actually equals 0. So, based off of what it's telling me here, is that this is going to result in an open circle. So I'm going to over-accentuate it, make a nice big open circle there. And then since this is greater than or equal to, this is going to become a closed circle situation. So, closed circle. So I'm going to do a closed circle. Let's try doing it like this. Closed circle situation. Oh my gosh. There we go, right there. All right, so now that we've done that, we've drawn the graph. And so we can talk about other components like the domain and range. Well, for the domain, if there's no restrictions, it's pretty much just going to be all reals. So that's what we'll do, is we'll say it's all reals, because we're looking at the x values, and none of the x values are being impeded. Like, the graph's going to keep existing no matter where we go along the x-axis. Same thing actually for the range here. So sometimes you got to watch out, because sometimes the range might be impacted. Like, you might have a graph that looks something like that. So, you know, it tops out at something or it bottoms out at something, but we don't have that here. So our range is also going to be fairly simple. All reals as well. As for the intercepts, we have a y-intercept at 0, 0, and then we have an x-intercept at -1, 0. There we go. That's all the information from this piecewise function.